Hello guys, my team is composed by Hudtler, Gabriel Ivón, Enrique Hernández, and me, Daniel Zugasti. And in this video, we will going to talk about friction. Well, friction, in simple words, is the force that opposes the motion. What does this mean? For example, here we have a box that contains a penguin, and if we try to move this box with 3 fingers, the box will not move. That force that opposes the motion, it is the friction. There are many types of frictions, but in this video I will talk about 2 of them. The first one is the static friction. That is the force that opposes the motion when the object is in rest. And the other one is the kinetic friction. That is the force that opposes the motion when the object is in movement already. Here we have again our cute penguin with the box, and if we try to move it with 4 fingers, the box, it will not move. But what if we try to move it with 5 fingers? The box will start moving. As you can see, 5 fingers, a penguin, and the box is moving. And if I take off 1 finger, the box will still be moving. Well, but then if you take off 1 finger, the force applied on the box is less. Well, yeah, actually the static force or static friction is greater than the kinetic friction. Well, what forces are being applied in this box? Well, if I apply a certain force to move the box, a force is applied to this direction and a friction force is applied to the opposite direction, okay? And then we have the normal force, that is upwards, and the weight, that is downwards.
Kinetic friction is proportional to the compression, which is equal in magnitude to the normal force exerted by the plane on the sliding object on its own. Force of kinetic friction equals coefficient of kinetic friction times normal force.
Well, for that, we are going to use this table of 1.6 meters of length, and it also have a width of almost 30 centimeters. Well, for our base, we're going to use this base of wood. For 0.2 kilograms, we're going to use this bottle. For 4 kilograms, we're going to use this color box. And to add the resting percentage of kilograms, that is going to be 0.6 kilograms, we're going to add this box of 0.4 and this suit of 0.2.
In the experiment we get the results that are shown in the table over here, and well, these are the different critical angles that we get in the different tests made of each one of the masses, and with that we calculate the average critical angle of each one that are also shown in the table. With this we get the mu of each one of the masses, with the formula mu is equal to tangent of the critical angle, and well, with that we compare them and we see that they are almost the same, just with difference in decimals. And with this we can confirm the idea that the mu is independent of the masses compared, and it totally depends to the material of the structures that are compared.
For the conclusion of our experiment, we found out that the coefficient of friction between wood and wood is 0.5, and in our bibliography research we found out that the coefficient of friction in wood is also 0.5, which let us know that our experiment was correct in our calculations. So, in conclusion of this class, this topic, we learn about friction and how we can apply it to our lives, like pushing objects, like between wood and wood, to even like walking, to know like in which objects you will slide down with different angles. So yeah, thank you.